troubleshooting system hardware. We're going to start with those core system elements. You're going to have certain tools. Multimeter for looking at power issues, a power supply tester. Power supplies go bad and you're not going to be opening, so the power supply tester makes sense. Memory tester to make sure the RAM is good. Although the operating systems now include testers of themselves to minimize the need for that. Loopback plugs to make sure the actual physical ports are good. And a power on self-test card to make sure the computer is actually operating properly. We're going to see a few things beyond this though. So on the electrical measures, measure electrical values with a multimeter. It can be digital or analog. More experienced people tend to like the analog one. Beginners tend to like the digital. It's easier to work with. Use it to measure resistance, voltage, current, and continuity. Looking for a break in a circuit with continuity. So to measure resistance, turn off the device you're measuring, disconnect it from its power source. You might need to connect the device from its circuit. Set the multimeter to read resistance. Touch the two leads of the multimeter together to show that you have no resistance. Then touch the black and red probes to either side of the circuit to measure it. Read the resistance from the meter's display. Measuring voltage, verify the power supply is on. Set your multimeter to read either DC or AC volts. If you're looking inside of a computer, it's probably going to be DC volts. If you're looking at AC power, well, it's going to be AC. Touch the black probe to the ground and the red probe to the spot where you want to measure the voltage. Read it on the meter's display. Be very careful when taking voltage readings as the computer is powered up. Changing the voltage, or if you accidentally bridge two circuits with the probe, you could burn out the motherboard or a device. Measuring current, break the circuit, insert the meter into the break. Ammeter doesn't require the break, but probably not going to be on the exam. Clamp ammeters are also often used to measure current flow in 110 and higher circuits. Measuring continuity, set your multimeter to display resistance in ohms and look for circuits with zero resistance. Also, you can use continuity mode if available. Now, power supply tester. Instead of using a multimeter to manually test a power supply, because no one's doing that any longer, how do you get those probes into those little tiny pins or plugs? It's hard. Now, power supply tester will vary. Some of them will take up to 30 minutes to validate a power supply is good. Now, if the power supply is bad, it could take upwards of about 0.30 seconds. You know, it's real quick. It's going to tell you immediately. But if it appears to be good, it could take a while to monitor the power over time. Follow instructions for your specific tester. Advantages: less susceptible to human error. Results are more conclusive and a lot safer to perform. You don't want to be sticking those probes into circuits. It's just not a good idea. This works. Now, AC power should be that nice, beautiful sine wave. Okay, but we do get power problems. There's a power fault, momentary or transient loss of power, blackout. Blackout is a total loss of power or prolonged loss of power. A sag, transient or low power level or momentary low power level. Brownout, prolonged low power, decrease in the voltage level, causes damage to equipment. Spike, transient or momentary increase in voltage. Surge, prolonged increase in voltage, can burn things out. And noise comes from dirty power, disruption of a smoothly varying AC signal. Remember, we want that nice, beautiful sine wave? Well, noise is putting little jagged edges into that sine wave. Not good. Now, the CPU is going to get power, 5 volts over a specific wire. And it's expecting that power to arrive at a certain time. When it gets that, it's going to say CPU is good, power is good. Power good signal arrives. It has to arrive on time based upon the voltage regulator. Now, getting into voltage regulator is going beyond scope of this exam. Now, loopback plugs exist for serial ports, parallel ports, network ports, USB ports. You plug it into the port, you send data out, the data comes back in. If you can read the data you send out, the port is good, it's functioning. You need appropriate test software to go along with the loopback plug. The plug by itself won't do the job. Power on self-test card. plugs into an expansion slot, reads the progress of the boot process, the boot procedure. Displays status with numeric codes or with lights. Included on some motherboards, they have little lights that come on or numbers that show, but this is pretty rare nowadays. Remember we talked about that CMOS battery several times before? Well, there it is, that little lithium cell, 2025 or 2032 most commonly. And if you need to replace the CMOS battery, you pop it out, you pop a new one in. So to replace it, record any custom CMOS settings you have, because when you take that battery out, they're gone. Power down your system, unplug it, open your computer's case, if necessary, move cables to allow battery access, gently slide the battery out of its compartment, discharge the CMOS memory using the motherboard jumpers if necessary, usually not needed. Insert the new battery. Sometimes if you're quick, you don't even have to worry about the data being lost. There's usually a capacitor or two that'll hold enough power to go for a few seconds, maybe a minute, so you may not have any data loss. Reconnect any cables you disconnected to gain access. Close the PC chassis, reconnect any cables and the power cord. Reboot your system. You're going to get a CMOS memory error, similar. Hit F1 to go into CMOS and enter the correct date, time, and any other custom values that you had. Save and exit. Now, BIOS update failure. This is going to be bad. Don't update the BIOS unless absolutely necessary. Never turn off the computer during a BIOS update. That'll corrupt it. Use the correct flashing utility. Follow the instructions exactly without error. Back up your old BIOS in case you need to restore it. Maybe the new BIOS creates errors, causes compatibility issues. So if you have a failed update, restore the BIOS backup. Boot from a floppy disk containing the correct BIOS and flashing utility. Set the flash recovery jumper switch on the motherboard. Reset the BIOS to default. Or replace the BIOS chip. Sometimes that chip is not replaceable and you have to replace the motherboard. Now, testing memory. Now, there's physical testers for memory that you plug the memory in, it'll test it. There are some utilities as well. MemTest86, free open source testing software for memory, and Microsoft Windows Memory Diagnostic, free, but not supported by Microsoft because they say they cannot validate every brand of memory. But they say this should do a decent test it for stability, and if it causes a crash, reboot the system, it knows where it crashed and what's likely to be the issue with the memory. Or you can boot from floppy or CD and run some memory utilities.